Hello everyone, this is Magnus, CEO and founder of Scientia, a startup dedicated to developing AIs for businesses. We like to say that we make math magic for businesses, and in the case series that we're recording, we'll show you guys where the magic comes from. In this video, we'll be talking about Abeona. Um, Abeona is related to logistics problems, and we did something a little bit different with Abeona than with the other AIs. We actually split it into two models modules. One module for supply chain, which is related to um, where should your factories be located, uh, where is the optimal sourcing, how you're going to transport the inputs to your factories, and then turn these inputs into final products and deliver them to distribution centers and then to the final their final destination and all that. It's an optimization for the whole supply chain, and there's also this different module which is the delivery module, which is called it's for the last mile uh, logistics chain, which is basically delivery. So this company was a software company that had a fleet management application. Um, like many of the, it was a startup that, like many of their competitors, I mean, did pretty much the same thing. There are a lot of fleet management applications that basically follow where the trucks are, where what is their cargo, how long they're taking, and it's just something to follow what's happening. They did have a routing algorithm, something very basic that didn't work, which is sadly also a very common situation that we face. There are a bunch of companies that actually try to build their different algorithms for different problems, and they spend sometimes years developing algorithms that end up not working, and we the, many times people actually come to us with a similar situation, already already pretty traumatized by their previous experience, but they're still interested in something that works. So um, we 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 usually either start from scratch or try to see what we can reuse of what the work that is already done. But I guess building algorithms is something very specific, and people should be careful who they hire when they want to develop something by themselves, right? And another very common situation as well, as you've seen in the other cases, lots of data and just sitting there not being used. So in the case of the this version of the delivery routing algorithm, Abeona took data from the fleet manager for the deliveries and the trucks, their capacities, where they needed to pick up stuff and where they needed to deliver them. Fed it to a genetic algorithm, and then got back optimal routes. Um, just to give you an idea of what is a genetic algorithm, which is something also very popular right now, it starts by creating different random solutions. So let's say we give it four different possible routing schedules, and then we evaluate to see which ones are the best. Of these four, we pick the two bests. We of these two bests, we reproduce them, which basically is trying to randomly mixture what what are the options that these different solutions took, and then we make four new solutions by randomly picking different pieces of these two best solutions and combining them. Right. So, for instance, this one here is just the same as this. This one took this green. Uh, well, this was the same as this one. This one took the purple part from this solution and the green part from this solution and made a new one. This water one took the blue. Is this blue? Well, this color from this solution and the red from this solution. So you are creating new solutions randomly. In this graphic, you're copying these two parents, but usually you randomly create four new solutions based on the previous two best solutions. Then you do something which is a random mutation, which is doing some minor mutation on this new generation, just to give it some randomness and try something new. And then again, you go back to finding the best results, reproducing the best results, mutation, and so on and so forth. Notice that since you're doing you're taking the best situations, which is pretty much survival of the fittest. In here, you're always trying to improve the solution, right? Because you're trying different things, you're trying variations of different things, but you're always doing variations of the best previous solutions. And if you guys want to look at what the problem looks like, let's say this is how the duration, how long it took for making all the deliveries. As you can see, the genetic algorithm starts by doing a bunch of random things, so it's sometimes it's better, sometimes not too good. Eventually, it starts finding ways to make better solutions, so the delivery time starts falling quite fast, and then it keeps randomly changing a bunch of different things and improving little by little. It starts getting ever harder to find ways to actually improve the solution, but basically this is what it looks like. It usually starts by finding very good solutions, and then it stops improving as fast. It's harder. It takes more generations to actually improve or reduce the total delivery time. So the genetic algorithm is going to create optimal routes and give back to Abeona, which gave this information back to the fleet manager that the startup had. So what they had before, if before they only had maps with with where the trucks were. Now they had maps with the optimal routes. They could generate much better reports. They actually had the optimal routes, which is something. There are many solutions out there as well, and they saw a cost reduction by 60% on their clients. The clients of this startup started seeing a reduction of on average 16%. Like many other of our solutions, Abeona is going through a bunch of improvements. It's getting a lot more functionalities, especially in terms of a dynamic optimization version, that instead of just doing the routes at the beginning of the day to see what would be the optimal schedule, delivery schedule, it's actually going to have a dynamic feature that as the day goes by, it can automatically gather new information on traffic, and it can recalculate the optimal routes if there are significant changes in traffic. So instead of having a static optimal route, you can actually update the optimal routes based on traffic, which is something that the literature has, but from our research, there weren't any companies doing that. We had one client that said that they were looking at a company that said that had something that looked like that, but that it wasn't working. So I guess it's going to be an interesting differential, something very special that it's going to be hard to find someone else doing it. So if you guys have if you have any questions, please feel free to ask. Stay tuned for more information, especially on the new features that we're developing. And thank you for watching.